Okay, hello. I am back. Oh, did I miss me leave? See me leave? Have a good day. And Creatix, yeah. That's kind of what I like about processing, is it's specifically designed like one kind of for beginners, but also to basically exposes a lot of stuff like globally. That's supposed to make it like reduce the friction to like just getting stuff happening, right? Because what I'm actually trying to do is very simple, right? I'm just drawing some images at some coordinates and doing some basic input. But there are other frameworks out there which there'd be a whole load more boilerplate required to do something like this. Like it can hit its limits in the sense that it's if you're doing a really big project, you just stack up tabs here, right? Like there's no real I don't think it does like packages or like much like organization beyond this, so it can be a pain if you're used to like how you would structure and organize a more involved project. But people use it for like like art installations and stuff like that. So they'll use this to make like some visual that gets projected, or it's got libraries for hooking in with like webcams and different sensors, so people will do these like audio-visual arty things. Probably that's kind of the camp of people I think who use it the most. But yeah, for me, it's something that I like it for prototyping these kind of self-contained things, and it happens to be Java, which is a language for better or for worse that I'm fairly familiar with. So yeah. Okay, so we've got this point now where we have this thing going on. I'm, again, as is customary, at the halfway point, I'm going to run through the code and add some more comments and clean this up a bit and try and do a quick recap of what's happening. So when we first set up, we create a window here. So we load our I'll call them our common image assets. So these are the things which you always need, like the background and the grid cells. There's some other stuff which is going to get loaded dynamically, which is like the particular images for the individual characters and stuff like that. But we don't necessarily know, or we don't want to hard code at least what those things are. We then create this empty grid. I've hard coded number 3 all over the place, but it's very much for now, it's very much a fixed kind of thing in Steamhounds, so I'm kind of okay with just hard coding the number 3. So we create a 3x3 like 2D grid. Then this is the meat of this thing, right? Is this library. And right now all this contains is a set of tile objects, which each have a name and an asset. Honestly, the name's kind of superfluous at this point. But I want to be able to define, as well as objects, I want to be able to define sort of compound objects, which are made up of these tile objects. And then I want to define battlefields, which are populated from these things. So ultimately, this is the core of what we're doing in terms of like the data structure, if you like. Then we just have some super basic rendering stuff. Draw the background. We have some code here to render the grid. So we have a variable here to keep track of our current position on the grid, and if, as we're drawing the grid, when we hit the tile that the cursor's currently on, we use a different image for it. That's how we indicate that it's highlighted. And then if there happens to be an object in the grid at this location, then we draw it. When we draw the image, we call this getImageAsset function. And we just have a little cache here so that we never reload the same image twice, so we just shove it in this dictionary. And then next time around it will be in there, so we'll return it straight from there without having to load it again. This is where we handle the keyboard input. comes in two forms. The first is just moving around on the grid, and the second is here, placing or kind of removing an object. Kind of what we're doing there. In this case, so we get this kind of toggling effect, which is, I feel like, fairly convenient for us. So now we can create these, now we can place these things down. We need to think about, I guess, like saving these layouts, if you like, or these arrangements, or these formations, or these, like, I kind of want to call it a compound object, even though that's kind of not a super nice name. So one question we have to ask is, how exactly do we store these, right? Do we have this object? Let me actually screenshot this for diagramming purposes. So we have this sort of arrangement here. And if we want this to be like a reusable thing which can be placed down into different battlefields, how do we want to think of this, right? We could think of this whole thing as an object, and then, you know, these are empty tiles, and then these ones are populated. Or maybe it makes more sense to think of like the bounding box for this thing. And why might this be interesting? It's because, well, if you think of things in this way, then it kind of implies that if anything else is going to get put down onto a battlefield, it's going to have to only going to have these three tiles to work with. Or do we instead want to think of it very much like a sort of dynamic shape like this, such that you know, stuff is free to be placed in all of these tiles around it. You know, and then maybe this whole thing would actually end up being placed. I suppose there's only two positions this particular object can go in, right? It can be at the bottom like that, or it can be sort of at the top like this, just shifting it all up one. Yeah, so how do we store these compound objects to kind of reflect all of this? So I kind of like the idea that we probably want to think of them as a bounding box, I think. The reason for that is, yeah, right, so there's an extension for this where you're allowed to like flip them horizontally and vertically, or yeah, rotate them like 90 degrees or any other angle and have them fit in. I think for what I'm going to try and do today, I probably won't do that. And also in Steamhounds, positioning is very much, you know, a position that's rotated by 90 degrees is really not the same thing, right? If you're standing behind somebody and then you rotate it, you're no longer behind them. So in terms of the gameplay, yeah. So I've actually made, believe it or not, made a system like this before where you can define it on a, this is for more like generating big tile maps, but you can define these objects, and that can also be done recursively, right? So rather than concretely defining this tetramino, we could say, oh, it's got like a character here, and then another tetramino here, and then it will go off recursively and fill that with another thing, and it can rotate and flip and scale them. And it's a very flexible, like powerful system, and you can generate like building floor plans and cities and all sorts of cool stuff with that. But for us right now, I'm going to think mostly, I think, about just the basics, which is like positioning this thing around. So I think it makes sense to think of it like as its bounding box, because then that at least implies, you know, if that's the position of it or something, it then implies all the possible placements for it, each of these two possible placements here, and then when we want to check that no sort of constraints are violated, we can then go in and check individual tiles, right? So we can say, I think the object is defined by its bounding box, but we'll still track like which specific tiles are filled, so that when objects overlap, we would then check in their like actual internal tiles to see which are filled. Yeah, and that will determine whether or not that's like a valid placement. So I think if I'm now going to create our compound object, nope, that's not spelled correctly. How do I delete? Okay, I may need to actually rename this file outside. This is another limit with processing. You can actually use it from within like Java IDEs. This little IDE thing they have is quite nice, but it does have certain limitations which can get frustrating if you're used to a more traditional, fully featured IDE. I don't know, maybe you're like a Vim person, I don't know. So I think what I'm going to do is okay, rather than storing actual tile objects to begin with, I feel like I need to store like IDs, which probably means I don't actually want. I like IntelliJ, yeah. IntelliJ is pretty good. I don't do much console stuff. Okay, so if I'm like on a console and I need to edit something, then yes, I will use Vim, and I will at least be able to like make a change and save and exit. But I'm nothing like a power user with already any like console-based text editor. It's nothing I like ever super got into. I can just about navigate around in Vim, but I know there's a whole lot more powerful stuff it can do. Oh, I can do like a search and replace as well. I suppose that's the limit of my Vim expertise. I also use like Unity and C#, so Visual Studio also. But I really like IntelliJ overall as an IDE. So I think instead of having a list of these objects, I kind of want to have them like mapped out by ID, because I feel like I'm going to be fairly often referencing them in that way. I probably don't even need this name. And I'm going to reorganize my library to be more like something like this. Oh, here's a fancy trick I do know in this editor. Ah. Oh no, forget my keyboard shortcut. Okay, I was trying to do that fancy like multiple cursor thing, but it seems that I've forgotten the command for that. Okay, so we've refactored these things so they now kind of work by ID. That's probably broken a couple of things in here. Okay, I've just made life harder for myself in one sense here. I feel terrible for doing this. No, okay, let's not do that. Let's not do that. Let's put this back to how it was, and if necessary, I can just create a little index by ID. Waste of time. There we go. It's weird, I've lost my search and replace box. Where are we? Ah! Okay, so kind of on our 2D array of tile objects here. We don't need an ID. Okay, that'll probably do what we need. Let's think about defining a couple of these. What would be nice if we could have... Let's add these to the library. Empty for now. What I kind of want to do is have a button which will just dump out whatever's currently on the grid and save it as a compound object. So I think the way we'll do that is let's call it S for save. So what we need to figure out is what are the bounds of this thing, right? So we have our characters down here. We want to form this bounding box, which means we need to work out what's the sort of, it's between like these sort of bounds here. So we need like the minimum and maximum in both X and Y, which will define the bounding box, which will define how big the array is that we allocate to sort of hold this stuff. Yeah, and then we will sort of output it into there. What it might be nice to have as well, actually, is a width and height for this thing. So, kind of need to scan over the grid and work out the minimum and maximum X and Y values. So this is often something I often find myself doing, is like finding the largest or smallest thing in a collection. Obviously in some languages there are nicer ways to do this with fancier, more declarative, expressive things, but if you're doing it manually, then you kind of just need to keep like a running track of what these things are, and yeah, it can be useful to set your counters initially to like these min and max values, and then I can do something simple like we already have an XY loop I can copy. So if there's something in the grid here, okay, so we kind of find the bounding box here. So there's a case where if we haven't put anything down in the grid, then this will never trigger. So we can do something like if this is the case, then we know that we've never found something, and I can just print something out. Otherwise, we can now construct an object. We know its size now, so it's possible that the thing, if it's just one object, then its min and max are all going to be the same, but it still has a size, a width and a height of 1. So this will give us the effectively the width. This will give us the height. And then create our little array, and then all we need to do is let's draw a diagram for this as well. So delete all of this rubbish here. So we started off with a grid. And let's say there were objects like here and here. We would then have identified, okay, this is like the bounding area for this. We know its width is 2. And the height is 2 as well. And then we'd allocate a little 2x2 thing for it. So what we now need to do is to effectively like copy this thing into this tile, thing into this tile here. So if these original coordinates were like this, they then need to be sort of transferred to these coordinates like this. So they need to kind of be offset, right? If this thing starts in 1, 1, and the x and the y are both kind of going to be offset by 1. So we can do that. Start at the min x. I go up to including the max x. Like this. And then if it actually contains something here, we want to write into our object at applying that offset that we talked about. Don't want to copy the actual tile object, we just want to copy its ID. Because this is going to get persisted, so we don't want to like start creating loads of copies of this thing. There's one like canonical thing in our library and we don't want to keep messing around like that. Okay. I think maybe what we do now is we just print this out quickly. Is this right? We shall see. Okay, yeah. So the reason I'm doing this is if so you have in general, right? You have like some list of numbers or something, and you're trying to find like the minimum and the maximum. Then one way to do it is something like you'd have like some nullable null. Let's just say we're trying to find the minimum, and then you sort of loop through and do something like, you know, if min is null, then min is going to be equal to this item. Otherwise, it's going to be equal to the minimum of the current minimum and that item, right? If that makes sense. Whereas if you set, hopefully you follow, right? You'd have to do, let me actually write this out. So you do something like, so you have like some array, and you want to find the minimum. You'd have to do something like int I don't know what language this is now. This is going to be some weird zombie code. Wow, I'm mixing like colons and brackets all over the place. But you know, this is a common like pattern, right? Yeah, you're keeping like a running track of the smallest number we've seen so far. But this is kind of ugly, and especially since I was doing this for like minimum and maximum for 2 axes at once, so like 4 different things at once. If I just say this is equal to some arbitrarily high value, then I can just say right, and that would just always kind of work. So that's kind of what we're doing here. But if we actually say max int, then we're not just using an arbitrarily high value, we're using like by definition a value which any other value is lower than. So it allows me to do this without any like conditional logic or like null checking and is this the first item in the list and all of that kind of stuff. Yeah, I guess another way I could have done it was like, actually no, I feel like this is the cleanest way to do this in a way. I'm sure with other languages which have nicer like null handling, there's probably just a succinct way which doesn't do this, but I don't know. I find this often is a handy little trick. Okay, what have I done now? Somehow managed to cause some weird error here. Let me reload this, it might be doing something it shouldn't. Yeah, that was weird. Okay, so what we have now is, let me make this console a bit bigger. Hopefully the ability to place down objects. Then if I hit S. Cool, this looks right to me, right? So we can see that it's first to raise X. Yeah, so this is seems to be doing what we want. If we add something else here, yeah, then we get a 2 by 2, and it's like if we're going by like X and Y, right? Then we're like X 0, then we have the engineer, then we have a null, then we have the ranger, then we have a ranger. Cool. This appears to be working, and it's creating this sort of bounding box for us. Yeah, warrior null, 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 ng, null, null, ranger, ranger. Cool. So we now have these compound objects, and I think it would make sense to start like populating these into our library, and then we can start thinking about having these things like randomly picked and placed around. So just gonna add that straight in like that. I feel like I'm still gonna print it. That's kind of convenient. Like I then want to overwrite this library file. That would be JSON. There's so many types of like buffers and builders and streams and stuff. I always keep track of what's the most efficient way to like just dump a string to a file. And what version of Java processing is even built on top of. See what processing does itself for file IO. Save strings. Okay. I think that'll do what I want. So it expects an array of strings and it wants to write them like line by line. I can just create an array with one string in there, which I believe will do what I need. Put file contents. Yeah, right. So I think new Java stuff has like this files thing, and there is like a write all bytes. There is a way to do that, but I don't know if it's... Yeah, I don't know what version this is using under the hood. Yeah. And this is, I feel like this is in the spirit of processing. This is inefficient. Like, why am I making an array just to have one thing in it? But I'm sure it's fine. So put this in there, press save. Didn't appear to do what I want there. Oh, okay. So let's put it out here rather than in the data directory. Let's try it like that. Pull my library in here. Create our layout, save it. Reload. Ooh, that is ugly. Okay. Honestly, that's probably fine, but I kind of want to turn on pretty printing. Okay. Ugly, but let's see if this does what I expect. Save. Cool. Okay, maybe a bit more verbose, more pretty printed than I would have liked, but that definitely seems to be doing what I need. So if I get rid of that and then create another arrangement here, save that in. Create a handful of these. Okay. Okay, now we have a library full of random assortments of character arrangements. We can now finally get to thinking about how we populate a battlefield, like given these objects and these constraints. So I feel like I will create a separate class for this. Call it solver. That's kind of what this is doing. It's kind of what we want it to return, right? Like a full grid. So we need to give it a library so it knows what the components are. And I feel like we also need to give it... Ultimately, there's going to be parameters, right? Let's just give it like a target for the number of objects. We can make this more fancy in the future. So, okay, now we're on to the sort of algorithmic part. For some, this is the fun part. And how are we going to approach this? I feel like the easiest way is just to do this super greedily, by which I mean randomly pick an object, randomly pick a placement, and then just place it down, and then try and place another object. And if we manage to hit the number of objects through that approach, then fine, we've done it, and we return our whole populated battlefield. If not, then we just kind of roll back. Yeah, I think we just like roll back and then try different arrangements. So we'll ultimately try every possible combination of objects and every possible placement for those. But it will do it in like a sort of random, sort of greedy fashion. So I think what we really need is something which will try to place like one object. Do we do this recursively? Yeah, okay, I think maybe doing this recursively sort of makes sense. Let's start with a library. Let's start with a grid in its sort of current state. And then a number of objects. Okay. So my idea is that this is like going to be a recursive function, which is going to do something like place an object, and then it's going to call itself. With one less object, right? So if we've just placed the last object, then we just turn the grid. Otherwise, we're going to do a bit of recursion, pass the library in, pass the grid in with one fewer object. Okay, hopefully this makes sense. Maybe not. I mean, I've done something sort of similar to this before, so I kind of know what I'm aiming for, but yeah, if people aren't following this, then please let me know, because I know it's kind of funky. So it's going to be possible that there's no possible solution, in which case we probably get like a null result at this point. So I think what we need to do is, well, we need to pick an object, and we probably need to like randomize the order in which we do it, so we don't always get the same result. So what I've done here is I've just created a copy of that list because I'm going to be messing around and like shuffling it around and things like that. How do I shuffle a list in Java? Shuffle that list. And we're just going to go through it. And then we now need to try all the different possible positions for that thing on the grid. So again, we're going to do like a recursive thing here. We're going to say, hey, place this specific object onto this specific grid. And what we want to do here is kind of try all the possible positions. So if we're putting stuff on a grid, what are the possible positions? We have our grid here. I've drawn a lot of grids today. And we have an object. Let's say it's like a 2x2. And it can kind of go, you can go here, you can go here, you can go here, and it can go here. Wow, that's super ugly, but hopefully you get the picture. You know, you can go here, 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 or here. So if this is tile like 0, 0, it goes like 1, 2, 1, 2. Let's think about placing it based on the top left. We know that 0, 0 is always conceivably like it might fit there, right? And then, so if you had a 1 tile thing, then it can go in any position, right? So its x can be anything and its y can be anything. But if it's like too big, then it's now limited, right? It can't be positioned here anymore because it would kind of overflow. So the x and y can always start at 0, and then how far down and right it's allowed to like slide, if you like, is determined by the width of the thing. So the minimum, you just think about it in one axis. We want to think about the minimum or maximum x position where we're allowed to place this. So for one block, it can go anywhere. For 2 blocks, there's obviously one less position where we can place it. So I guess we'd say like the min x is always 0. But the max x is going to be, so I guess the starting point is 2. And then minus probably the width of the object minus 1, if that makes sense. If the width is 1, then we want this to be 2. The width is 2, the maximum x is 1. That's as far over as it can go. So that I think should give us that corresponding set of positions there. So it's not a tile object, it is a These are compound objects. Okay. We're not placing individual tiles, we're placing compound objects. Kind of what that represents. Okay, and then we're able to iterate over all of the possible positions here. But I kind of want to randomize these, so I think, I could just do, or in a way, excuse me, in a way I think I have to do this kind of thing where I loop over all the positions. But I think that rather than just immediately trying to place it in this position, I'm just going to create a list of all the valuable. Yeah, so I'm trying to figure out. So basically, given a 3x3 grid and given an object of a certain size, I'm trying to figure out what are all of the positions where the object can be placed, with a position being like the top left, so like this tile of the object. Yeah, so it can be 0, 1, or 2. The grid's 3 wide. I should probably have a constant for like grid size. Maybe I'll do that. In fact, maybe I will do that. That's probably a good thing to do because it makes it. Yeah, the grid's right there, but if I put the number 2 in, if I do grid size -1, I feel like that's way more indicative of like what conceptually it actually means, so that's kind of why I like this, right? Like what was that number 2 before? Like who knows? But I mean we know, but hopefully this makes sense. I feel like that's much nicer in a way to do it like this. Even if it's only ever going to be 3. And I know this factors out in a nicer way, but to me this is still clearer what it's actually referring to. Yeah, so now this is like a valid top left placement for this object. So I think I'm going to create a list of these. I'll use a vector to store that. We can say cool. So I have a list of legal positions. Now I can say I can shuffle those. And now I can sort iterating through these, I think. It might be nice if we... Actually, I think that, yeah, the first time we run this, I'll just step through with the debugger. I think it should be fairly reasonable to see what's going on. think this is what I actually want to do. No, it's not. Okay. I'm thinking already about like failure conditions, or where we like paint ourselves into a corner and can't place another object, but I feel like I can probably handle those later. So at this point we have, draw another grid. At this point we have our grid, and we know that we're placing down, say, a 2x2 object. So we know that the possible positions for it are these ones, whereby if it was placed here it would occupy that space. So we can then like randomly pick one of these. Before we actually place it though, I mean, in terms of its width and height, this is a legit position for it, but we should probably consider the fact that another object may already be occupying like one of these tiles that we care about. So we kind of need to query the existing placement of stuff on the grid and say, hey, is there anything in these tiles which is going to cause an issue? I think the way I'll do that is so this X and Y are like the local coordinates, so I'm iterating over these points. I then need to work out, okay, translate that into like the space of the grid, what's the corresponding coordinates, and is there already something placed there which is going to block me? So I'll call this like world X equals X plus. This is another super common thing in game development, is the concept of local coordinates and world coordinates, and having like a world to local and local to world. Because when this compound object is sitting in our library, its space is only big enough to like contain whatever's in the object, but it can then be placed somewhere else in the world, so we need to sort of convert from one coordinate system to the other, which is just offsetting it by its sort of position, which is what we're doing here. So if so if there's something here and then we've got a collision, right? So we should probably we break out of that. I'm also going to say if we're not overlapping, then this is where we're going to place it, right? Okay. Okay. So it's actually very similar to what we're doing here. Iterating all of the tiles of our object, and then we're going to, if there's something here, then we're going to also update the grid. I feel like we don't need the library here actually to look up the actual tile object. Break 2. Okay, so there is a... Yeah, I kind of feel like I should have done that. So there is... I think you do it like... Do it with a label. I think that's the way you do that. It's a go-to, right? It's just a go-to. But we're not allowed to use go-tos because they're apparently really terrible, so... Yeah, I think that's right. I think that breaks out to that point. We can check it in the debugger, but that should do what we need, I think. So this is kind of be messy and inefficient for now, but... What to say... Yes, good catch. Thank you. So in this case, we've managed to successfully place this object. If we get to the end, and that didn't happen, and there was no legal position, and that's a failure state. Yeah, I feel like I've written a lot of code before running anything, so... And there is a lot going on here. Okay. What I think I'm going to do is, yeah, run this in the debugger and see where that gets us. So let's try something like... Yeah, lots of loops. This can probably be cleaned up, but let's run through and see what happens. Doesn't like that. Okay. And I think what I'm going to do is have a diagram sort of going along with this so we can keep track of what it's doing. So I have my little variable watch window, which you probably can't see. How am I going to do this? Okay. Step in here. Oh, just press continue. That was not good. Start again. Where are we? Okay, so we build a list of all the objects. We then shuffle those. So now we have this objects array. Just has some shuffled set of all of these tile objects. Or these compound objects, sorry. Then we're going to consider the first compound object. Okay. O has a width of 3 and a height of 1. So, which is what we're dealing with. So logically, it can go here, it can go here, or it can go here. And hopefully the code reflects that. So we run this function to place it. We figure out the minimum and maximum x and y. Okay, so I don't know if you can read this very clearly. The max x is 0, the max y is 2. I think that makes sense because this is 0, 1, and 2. So the only valid x coordinate is 0, because if it's x was 1, then it would go off the edge here, but the y is not restricted. So there are 3 potentially valid positions where this could go. So we should hopefully see it build up that. So now we've got this set of legal positions. There are 3 of those. It's probably then 0, 0, 0, 0, 0, 0, 0, 2, and 0, 1. So it looks like it has a random set of positions. Any one of these should work. It should be able to fit in there. So let's check here. So this position is 0, 0. So the first position it's considering is in fact this one here. Then it's going to check that there's nothing already existing in those cells. We already know that's the case since this is the first object to be placed down. So I imagine it will just loop through without detecting any overlaps. Okay, no overlap, so it's now going to try and place the object. So it's going to go through, populate the world, grid, with those objects. Boom, that's one object to place. So if we now check this grid variable, you can see that structure may not be super clear, but we have... Okay, so it looks like we've done the row of ranges here. So it looks like it's put a row of ranges in the top, which seems like that's legal, right? It can do that. So now hopefully when it tries to place the next object, we should see that it works around that and doesn't place anything in a way which would overlap. So now it's going to recurse here, so now it's only got one object left to place. Okay, it's going to shuffle the objects. It's going to pick one of them. Which one is it? Okay, it's a 2x1, so that means we know that these tiles are already filled with warriors, with rangers, sorry, so if there's a 2x1, you can go here, 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 or here. Oh, okay, I've just skipped right over that whole recursive call, but we can at least check the grid, see what it's done there. Okay, looks like it's put it in a corner, so cross my fingers now. That's number is 1, so it's going to return. Nope. That's weird. What's the number of objects? 2. Awesome. So it looks like it has placed these things in like a legal shape. Maybe what I'll do is add a little keyboard shortcut now. By the way, this is success, right? This is we wrote a whole load of code there to have this little basic first pass of this constraint solver, and it appears that it has worked. So I think what I'll do is I'll just add a keyboard shortcut to generate more of these so that we can cycle through loads. Cool, super cool. Yes. Okay, so if the key is that, then let's just have it do another solve. So we can see what combinations of things it can generate. Okay, we are definitely getting somewhere. However, I think there are a couple of edge cases. Basically, I think it won't properly handle the case where it sort of paints itself into a corner and needs to like unplace an object. So let's say we had a draw a grid for the 99th time. So we have a grid, and let's say we only had like 3 object types. Let's say we had like a one like this, one like this, and then I don't know, just like a 1x1, like a simple one. Yeah, if you place this. Yeah, so what you kind of want to do is, right now it like opportunistically places stuff, right? Well, let's say, okay, let's say any of these things exist and we need to place 2 objects, right? So if it places this one first, or, yeah, that's a bad example. Let's say there's a couple of these horizontal ones, and we want to place like 3 objects is the target, then it can place that one, and then, you know, maybe it can place that one, but then there's nothing else, right? Like there's nothing left. So what it should actually be doing is kind of recursively like rolling back and going, oh, okay, maybe I'll place it here and then see if that gives me space to place something else. And, you know, no, there isn't. And then ultimately it should try this in every position, probably. And then ultimately it should go, okay, there's no like way to place a 3rd object, so I need to now roll back my little recursive stack one more level and get rid of that thing, and then now maybe I then try and start by placing another object first. So yeah, it needs to like, if it hits like a deadlock, it needs to roll back one level, and then maybe try different positions. And then if none of those positions, if those all result in a deadlock as well, then it should try a different object entirely. And then there's always the case where it tries every object in every position in every order. It feels pretty exponential and like crazy to do it in this sort of greedy way, but in my experience, for reasonable sized problems, like with even like looking at hundreds of tiles and stuff, it actually can work. So I feel like we need to add. So in terms of where we place an object, so this will already try multiple positions, but the problem is a position can be bad not just because there's no space for something, but because if you then go on to place the next object, then it like blocks it out. So I think actually the way we kind of need this to work. Like truly recursively, so when we place this thing here, we don't need to return, we actually then want to yeah, so I think the way the recursion will work is that it will systematically try every possible combination in every possible order. So it won't recurse forever, it will actually reach the end of all of these nested loops will reach their end. And it will just fail. I think that's okay. I think the way we do it is, okay. First of all, I think we need to start creating different copies of this thing, because if we've got this big recursive stack of things, we can't be just mutating the same grid as it gets passed through these recursive calls. We need to start copying it. So I think I need a little function here to like copy my grid for me. So I think start to get to the point now where my ability to like talk and keep all of this stuff in my head getting a bit strained. So rather than returning here, we actually need to say, we need to do another recursive call here. Okay, I think this will kind of work if we can try and walk through this. So, what's the problem? It doesn't always return. So let's actually set up a situation where this is bound to happen. If I remove these compound objects, we can set up like a pathological case with like deformable objects, which are going to make this happen. So if we place down first, let's have an object which is horrible and will never work. One like this. One like this. And then one like So this object is like a 3x1, so it's going to put this somewhere. It should have no trouble finding position for it. So we now have grid, and the position it's chosen is x is 0, y equals 1. And I'm assuming it will have no trouble placing this down, so it should end up like these tiles. Check for overlaps. Doesn't overlap. Gonna try and place it. Gonna populate the grid with those objects. Not going to return because the number of objects is still 2, but it will recursively call. Yeah, I think this is where I needed to say. Copy that. Yeah. Then picks another object. That one won't fit. Okay, so it's picked a 2x2 object, and there's no way that can fit. If it had placed this like on the top or bottom, then it could fit this 2x2, but it won't manage to do that. So I expect what it will do is it will go through every position, it will try and place it. The result will be null. Okay, got output no legal positions for object. So what it should do next is it should try the next object, which is what it's doing. I think the issue is that... Oh no, okay, we're okay. So, yeah, what object has it picked? Another 3x1, this is fine, so this should just work. Figure out the possible positions for it. We'll pick one of those positions. So it's picked the wrong one. So it's got another 3x3 shape. It's picked this position again, so it's going to overlap and that's going to fail. So we should see it try another position after that. Yeah, overlap happens straight away. It breaks. Try another position. This one is 2, 0, so it's looking now 0, 1, 2, so it's now looking down here and it should have no trouble placing it down there. Check for overlaps. There are none, it doesn't overlap, it's going to copy itself into the grid. Okay, so it's going to try and place an extra object. I had an off by 1 error there. Cool. So I think fixing that off by 1 error, it was trying to place one more object than it should have done. If this is like the last object, then we're all good. So now I can generate. Awesome. This seems to be doing pretty much what we need it to do. I wonder what happens if we try and get it to put 3 objects in there when we know 3 objects is not going to fit. Oh, okay, yeah, there are 2 ways. These are the only 2 ways to fit 3 objects in. But 4, there is no possible combination of 4. Yeah, okay, we got a null pointer exception. So, no possible solution. Okay, it actually detected that properly. You just have it return that grid in any case. The original grid. Awesome. So this thing now is doing what we want. It's trying every possible combination. Let's maybe create a couple more variants for it to play around with. Okay. Oh, something's happening it's not liking here. Am I still telling it to generate? Okay, something's weird and it's getting all the way up the stack without realizing there's no results, so let's see what's going on. It'd be real nice if I could see a stack trace here to figure out what's going on in terms of recursion and stuff. So we reach a point presumably where it fails to place any object, and I feel like it's maybe not rolling back in the way that it should. might help is if I could see have a sense of like the depth here. Probably what's happening is stuff is getting placed in this case, but it's some of this grid copying is resulting in like an empty grid being passed back up. Try and place an object. I think what we want to do is something like dead. Yeah, so I think I have a mix-up of... Because basically you want to... First you're trying out different candidate objects, right? So you want to like... you have like a perspective grid, like I'm going to place this object here provisionally, and then I'm going to try to recurse further and place other objects around it. But whenever you fail, you have to roll back up one level and undo all of those changes to the grid. So at some point, something weird is happening and my grid is getting, yeah, like one of the copied grids. I'm never like applying those changes, or the grid that gets passed back up at the very end is empty. So maybe what I'll do is add a breakpoint here, so that whenever I return something up the chain, I can see what's going on. Don't care about that. So here's my grid copy, which has some data in it. Probably the grid that got passed in. The clean grid does not. That looks as I would expect. So then we recurse into this. then I can continue until we place the next object. That's fine. Eventually place something, then we look in the original grid had that first object in. Our grid copy has... Oh, okay, I think I know what's happening here. Okay, no I don't. So this is... Yeah, there's now more stuff in this grid than there was before, which is what we would expect. Yeah, let's place another object like in the top row here. If I continue, something else, what does the grid look like now? Still got all that stuff in it, all good. Continue, another failed placement. Grid is still full. That again. Yep. Okay, now we successfully placed something. The old grid had 1, 2, 3, 4, 5, 6 spaces filled. The new grid has 1, 2, 3, 4, 5, 6, 7 spaces filled. At this point, I believe we are good because this is the last object. Okay. And then we turn back up the chain. Step the result should be a non-empty grid, which it is. All the stuff is in there. We then turn the result. Okay, that's weird. So we've succeeded, but we've then come back up to this point. Okay, yeah, we've gone back one step up the chain. The result is going to be not null. Result has stuff in it, so we're going to return that again. And now we're at this point. Step, the result is nice and populated. We're going to turn that again. It's right at the beginning. Step over that. The result is still populated. Okay, step back up. Step over. The result still has loads of stuff in it. That should get turned. Now we're here. Okay, that's right. I did all of this. Filled out this result variable and then just returned an empty grid. Which I should do probably like here. Otherwise I should return the result. Okay, that's what it is. I just discarded the result right at the end and still used the original like pre-empty grid. Whew, okay. I think I got it. Okay, I'm pretty confident this is now working. So even with like the more complex shapes. The way I did this, by the way, was each compound shape only had one type of thing in it. So this is actually like a cross-shaped thing that's in the... This is a tetramino for this kind of shape, and then it's managed to fill the gaps. So there must have been quite a lot of trying things out and then having to roll them back because they didn't fit in these gaps. Cool. As you can see, it's like a relatively quick at doing this, even though there's a reasonable number of like permutations it's having to consider here. Cool. So I think this is about where I'm going to leave it today. There's a load more stuff we could do to add on to this. I mean, right now we're only showing like characters here, whereas actually these will be things like terrain objects as well. But even as it is, I think it more or less, the logic is more or less the same. There's some other cool things you could do by way of extending this. Something which this doesn't quite allow you to do is like what, let's say, this is our battlefield. We can create like a row of warriors, right? Or a column of warriors, but it's still then free to like place those things in any of the other columns. So there's ways to layer more constraints, like, right? Like what if you wanted to have warriors, but you wanted to be able to say, hey, there should be like, I don't want them on the back row, right? So let's say you had like something to indicate that there should be like empty space behind them. That means that this would become an object like this. So it could be placed like one tile back to put warriors in the middle, but it would never put them in the back row. Or if you specified like this should be empty as well, then it will kind of specify them there. So you can set up these more complex constraints which aren't exactly tiles, but they're like, don't know how you describe them, they're like placeholders which have some like effect on the constraint system but don't actually end up in different objects. So you could say, yeah, you could have like the idea of an empty space tile which would allow you to say, oh, I want a warrior in the front row, and that's just like a warrior, empty space. So then you're just creating more restrictions on where that can be placed. Or you can do cool stuff which like refers to other tiles which haven't been placed yet, for example. Like, let's say I want a warrior and there can be somebody behind them, but I don't care who they are. Then the way this would work is if you have a battlefield like this, and let's say there's like a chemist here and there's like an engineer here, then legal placements for this tile would be like here or here. So as well as these, the basic constraints we have right now are like the bounding box of an object needs to fit in the grid based on where you place it, and then you can't have overlaps between these objects. But you can have other types of constraints, like, yeah, there must be a tile here whether there's something in it or not, or there's a tile here and it like absolutely must be empty, like there can't be a character behind me, or there needs to be a character with certain properties kind of behind me. Like something we looked at on the original little sketch here, but I don't think we ever got to, is the idea of tagging these things with certain properties. Right now the only parameters we're sort of putting in are there should be 3 objects placed on the battlefield. But you can do some more fancy stuff with like filtering out, and maybe I'll do this on a future stream, but like basically there's this point in the solver where we say, oh, I want to place an object, and I just took the list of all objects as like viable objects, but you could do other filtering at this stage, basically like based on tags. Like it must be an object with this tag, but it can't have this tag, so you can have like a Boolean logic sort of thing, and if you layer that on top, then you have a lot more creative control that would allow me to say I want a battlefield with like 1 object tagged as an obstacle and 2 objects tagged as single enemy character and also tagged with like a particular in-game faction. So then that would create a more kind of tailored battlefield like that. So maybe that's something I'll do on a future stream, or maybe that's not visual and interesting enough and it's too dry and boring, so maybe not. But yeah, as it is now, the core of it's there. We have this like recursive solver thing working, and it hasn't crashed yet, so I think we'll call that a success. Thanks anyone who tuned in. I'm going to throw a couple of links in the chat. So I've started regularly posting a poll on our Twitter the day before these streams, where people can vote on the subject. So there's the URL for that. And if you want to play the game that this whole thing relates to, then you can just jump into our Discord, where we're doing our open playtests for Steamhounds. We're doing a tournament tomorrow, actually. Yeah, thank you. Yeah, I think shall we raid somebody? We got raided today. This has never happened to me before, so let's try and find someone cool to raid. Who's streaming right now?